Welcome to C3's February Junior High Marathon Task, Radical Roller Coasters. This video will be about the background information needed for our task. So, many of you most likely know what a roller coaster is or have even been on one. And roller coasters are ways for people to explore how close they can get to the impossible and experience extreme conditions. Roller coasters use a variety of materials, elements, and there's history to certain roller coasters. There's many different kinds of roller coasters worldwide. And so let's take a look at some worldwide extreme roller coasters. So first up is King Dakar in New Jersey, USA. Its extreme element is that it's the world's largest drop on a steel roller coaster, with a drop height of 127.4 meters. The speed at that drop, it goes from 0 to 206 kilometers an hour, and the total ride time is 50 seconds. And riders will experience 5 Gs at the max of the drop. A G force is basically just how much gravity you would feel pushing down on you. If you ever have been on a roller coaster before, you do feel that force on your body. So a G force is a rough measure of that. Next up is the Beast in Kings Island, and it's the world's longest wooden roller coaster. It was designed about the use of scientific calculators and computers, so it was designed about the 1970s. And it's very impressive that it's still functional today, even though it's made of wood and was used with was made with rough approximations. That's why it's called the Beast, because it was a beast of a project to take on. Its speed was 104.25 kilometers an hour, which is impressive for a wooden roller coaster. Next up is the Steel Dragon, which is the world's actual longest roller coaster, regardless of material, with a total length of 2,479 meters. It's located in Japan. And then there's the world's fastest roller coaster, which is the Formula Rosa in Abu Dhabi, United Arab Emirates, with a total ride time of 1 minute and 32 seconds. It goes to speeds of 240 kilometers an hour in just 4.9 seconds. So immediately at the start of the roller coaster, you're off. And then lastly, it's the Tower of Terror, which its extreme element is that it has the world's highest G force on a roller coaster that's still functioning. That side note is that certain roller coasters have been able to achieve higher G forces, however, they were deemed as unsafe. So those roller coasters aren't up anymore. And it mainly consists of a steep drop of nearly 90 degrees down. Now, a lot of things need to be taken into account when people design roller coasters, so let's take a look at some of the elements we need to consider. So there's two types of roller coasters, inversions and non-inversions. Now, obviously, a roller coaster can have a mix of both, but we can classify them as two. Also, you can find more examples at the link. So inversions are roller coasters that will invert you, basically turn you upside down, as you can see from the photos. Non-inversions do not do that, but they can still be extreme in their own way, as you can see in the pictures. You don't need to be inverted upside down for a thrill, but it certainly is extreme. When designing a roller coaster, you also need to take into account safety precautions. So the G-forces we explained earlier are a bit difficult to calculate, but you can tell when it might be too much for riders to experience. And at the link, you can play around with building some models of roller coasters and watching how the forces interact. Roller coasters are also slightly dangerous. For example, some of the turns, your shoes could fall off, some they could fall off your pocket. So they have nets set up. There's seatbelts and handlebars to keep people pressed down, as you can see in the picture here. It's so that the G forces or any other forces don't fling you out of your seat. There's always escape ladders in roller coasters just in case if they stop, and sometimes rain suits can be offered if water is involved. And lastly, there is speed, one of the most exciting parts of roller coasters, how fast you can go. But the speed can be difficult to calculate at a basic level, since there's so many factors to consider: air resistance, friction, but you can find the average speed by just taking the total distance of the roller coaster and dividing it by the total time taken for that roller coaster to go. And the average speed would be the same for a small model of the roller coaster and its large real self, which is pretty cool.